So in Unit 4, we're going to go over radicals, and 4.1 is going to be roots and radical expressions. But before we can get to the problems, we've got to take a look at some information you're going to need to be able to solve them. So if you have x to the n, we're going to call this a power. So the entire thing put together is called the power. The x is the base, and the n is the exponent. So if you have 2 to the third, 2 is going to be your base, 3 is going to be your exponent. The 3 tells you how many times are you going to multiply the base against itself. So 2 to the third tells you 2 times 2 times 2, which is 8. The opposite of a power is a radical. So what we're going to see when we look at a radical is we've got the radical sign, which is the little check mark looking thing that you're probably used to seeing. But then also notice that there's a number in the crook of that radical sign. This is called the index. And then the radicand is the letter or the number that's inside of the radical. So what the index tells you is how many times you're going to multiply a number times itself to get the radicand. So if we have the cubed root of 8, that means the third root of 8, then what we're looking for is what number are you going to multiply against itself 3 times in order to get the number 8. That would be the number 2. 2 times 2 times 2 is 8. So the cubed root of 8 would be 2. Now, if you ever have a radical sign that doesn't have an index, it's automatically assumed to be 2, or the square root. Now, more information that you're going to need concerns properties of powers. And this has to do if you've got positives or negatives sitting in front of your powers. So if you have 2 squared, that's positive 2 squared. And what that means is we've got positive 2 times positive 2, which is going to equal 4. Then you've also got the quantity negative 2 squared. So negative 2 inside of some parentheses. This means negative 2 times negative 2. And again, that's going to equal 4. Then you have a third type, which is negative 2 squared. And what that is there's a negative sitting out in front of that 2 squared. Remember that anytime you have a negative number, or a negative sign, that represents negative 1. And in this case, this is negative 1 times 2 times 2. Because that negative isn't inside of parentheses with that 2, what that's telling us is we've got to use the order of operations on this. So we take the 2 squared and we do that first. 2 squared is 4, then times the negative that's sitting out in front, or the negative 1 that's sitting out in front, and that gives you negative 4. In problem number 1a, we're going to look at finding all real roots. So it asks, what are the real cube roots of 0.008, negative 1,000, and 1 over 27? So let's start with that 0.008. We're going to put that under a cube root. So the cube root of 0.008, and what I like to do with this is I like to think, how many times would I need to move my decimal point over in order to get to the very end of the radicand? So I would need to move that decimal point 3 times. What I'm going to do is I'm going to say, if I need to move it 3 times, I'm going to divide that 3 times by the index of 3. So what that then tells me is that I'm going to be dealing with a number that is only one place behind the decimal point. So 3 divided by 3 means I'm just going to move the decimal point 1 to the left. Now the second part of this is I want to think, forget about the 2 zeros that are out in front. Just worry about that 8. What is the cube root of 8? It's 2. So now if I apply what I just did a second ago with the dividing the number of decimal places that I've got by the index, 3 divided by 3 is 1. If I have 2, I'm going to move that decimal 1 spot to the left, and it's going to be 0.2. So what that tells me is I can break down that radicand into the cubed root of 0.2 times 0.2 times 0.2. If I do 0.2 times 0.2 times 0.2, I get 0.008. So basically what I've got here is the cubed root of 0.2 cubed, which means that the answer is 0.2. Then we'll take a look at the cubed root of negative 1,000. Okay, forget about the negative for just a second. What's the cubed root of 1,000? Well, 10 times 10 times 10 would give me 1,000. And again, this is a little bit simpler because how many zeros do I have lined up after that 1? I've got 3 zeros lined up after the 1. The 1 is the only other number. So that means that I'm going to basically be dividing the number of zeros by the index. And that tells me I'll have 1 0 for my answer. So then we have to deal with the negative. Well, a negative times a negative is a positive, but times another negative is again a negative. So that tells me that the answer is going to be negative 10. Then you have the cubed root of 1 over 27. So what we can do with this is we can break this down into the cubed root of 1 times 1 times 1 over the cubed root of 3 times 3 times 3, because 1 times 1 times 1 is 1, and 3 times 3 times 3 is 27. So you get the cubed root of 1 cubed, and you get the cubed root of 3 cubed. Well, each of those, the cubed root of 1 cubed is just going to be 1. The cubed root of 3 cubed is going to be 3. Or if you just memorize, the cubed root of 27 is 3. So your answer is going to be 1 over 3. In problem 1b, we're going to be looking at fourth roots. So what are all the real fourth roots of 1, negative 0.0001, and 16 over 81? So the fourth root of 1 is simply just going to be 1, or negative 1, because we can do 1 times 1 times 1 times 1 will give us 1. Negative 1 times negative 1 times negative 1 times negative 1 will also give us 1. So the answer is going to be plus or minus 1. Now for the fourth root of negative 0.0001, we're taking and we have an even numbered index. Anytime that we have an even numbered index, that tells us that the radicand cannot be negative. So as soon as you see that you've got an even numbered index and a negative radicand, automatically know that that is going to be no solutions or no real solutions. Your only answers could be imaginary. For the last one, the fourth root of 16 and the fourth root of 81, well, what number times itself gives you 16? 2. What number times itself 4 times gives you 81? 3. So the fourth root of 16 over 81 is 2 over 3, or negative 2 over 3, so plus or minus 2/3. For problem 2a, we're asked what is each real number root? The cubed root of negative 8. So the cubed root of negative 8, again, think about it this way. Since you've got a cube of a negative, you've got an odd index with a negative radicand, that automatically tells you the solution is going to be negative. So just write a negative down there. Then what number times itself 3 times equals 8? 2. So your answer is negative 2. For 2b, what is each real number root? Square root of 0.04. So what is our index this time? The index is 2. How many decimal spots has it been moved over? 2. So divide 2 by 2, that tells you 1. So we know that our solution is going to be behind, or is going to be in the 10th spot when we're doing place value. Now, forget about the 0.0. What is the square root of 4? It's 2. So you get 2, move your decimal point over 1 spot, so your answer is 0.2. To go back and check yourself, what is 0.2 times 0.2? It's 0.04. For 2c, we're asked what is the fourth root of negative 1? So again, we're dealing with an even index and a negative in the radicand. That tells us there can be no real solutions, so your answer is no solutions. In problem number 2d, we're given the square root of negative 2 squared. Now, before you write this off and say that there can be no solutions, you've got to work out the radicand first. So use order of operations. Negative 2 squared is 4. So we're really being asked, what is the square root of 4? Square root of 4 is 2. So there's your solution. some more information that you're going to need with simplifying radicals. If we have the cubed root of x to the 7th, and we want to simplify this radical, then what we're going to do is this. We're going to take that 3 that's in the index, and we're going to divide that into 7. What that would give us is x to the 7/3. So how many times does 3 go into 7? It goes in twice with 1 left over. So what you would do is you would pull an x squared out from underneath the radical, and you would leave 1x in underneath the radical in the radicand. So your solution would be x squared cubed root of x. So you divide the exponent by the index and think of a fraction. The quotient is the value of the exponent taken out of the radical sign. So it went in twice. So we take out an x and put a 2 where the exponent goes. The remainder is going to stay in the radicand, and whatever the remainder is, that's going to be your exponent on that particular base. In problem 3a, we're asked, what is the simplified form of the square root of 16x to the 8th? So the square root of 16x to the 8th is the original problem, and what we're going to do is we're going to say, what is the square root of 16? So what number times itself equals 16? 4. Then, how many times does the index go into x to the 8th? So the index is 2, so divide 2 into 8. So 2 goes into 8 4 times exactly with no remainder. What that means is we're going to pull out x to the 4th, and that's going to go outside of the radical. So 16 is a perfect square, so 4 comes outside of the radical. And then since x to the 8th is also a perfect square, we're going to pull x to the 4th outside of the radical. And that means that the solution is going to be 4x to the 4th, and there's not going to be any radical left over. For 3b, we're asked, what is the simplified form of the cubed root of a to the 6th, b to the 9th? So again, we're going to take that index and we're going to divide it into both of those exponents. So how many times does 3 go into 6? It goes in twice, exactly. How many times does 3 go into 9? It goes in 3 times, exactly. So we have no remainders, which means that there's nothing left in the radical. So 3 goes into 6 twice, that means we have a squared. 3 goes into 9 3 times, so that means we have b cubed. So the answer is going to be a squared b cubed. In 3c, what is the simplified form of the 4th root of x to the 8th, y to the 12th? So again, look at the index. The index is 4. We're going to put the index into both exponents. So 4 goes into 8 twice, which means we're going to have x squared. We're going to pull that out. There's no remainder left. The 4 goes into 12 3 times, so we're left with y cubed. There's no remainder, so both of those things come out of the radical and there's nothing left inside, which means that we have x squared, y cubed is our solution. For problem number 4, we're going to take a look at a word problem. It says some teachers will use the formula a equals 10 square root of r, where a is the adjusted score and r is the raw score, to curve assessments. If the raw scores on one test range from 36 to 90, what is the range of the adjusted scores? So a raw score is just what did you get on the test without any curve. So if you have 36 to 90 as your range, all we're going to do is we're going to plug 36 in for r. We're also going to plug 90 in for r. So a equals 10 square root of 36, and a equals 10 square root of 90. So square root of 36 is 6, so 10 times 6 is 60. Square root of 90 is 9.49, so times 10 is 94.9. So the range of scores would run from 60 to 94.9 using that formula.